करोगे तो दिमाग में बैठ जाएंगे,
हाँ सर।
राइट?
यस सर।
फिंगर टिप्स तो है ही आपके पास।
हाँ।
ऑलराइट, गॉट इट। तो आइए बात करते हैं न्यूटन्स लॉ। सो द व्हाट इज द फर्स्ट लॉ स्टेट? न्यूटन्स फर्स्ट लॉ। Just to give you a context, the chapter we have studied so far, right? First was the kinematics, जिसमें we studied motion.
यस सर।
But what we did not study was the why of motion. होता क्यों है motion? सिर्फ हमने पढ़ा कि there are motions which are uniform motion, and we studied the non-uniform motion. That's all we studied. So इसमें हमने पढ़ा था velocity is equal to displacement upon time, और एक हमने पढ़ा था यूनिफॉर्म मोशन के अंडर यूनिफॉर्म एक्सेलरेटेड मोशन। ठीक है जी? सो विच वॉज v इज इक्वल टू u प्लस 80। ये तीन इक्वेशन पढ़ी थी हमने, ये 9th में भी होती हैं, राइट?
v equal to u square plus 2a।
यूनिफॉर्म तो, और नॉन यूनिफॉर्म के अंदर वी वर यूजिंग टेक्निक्स ऑफ कैलकुलस,
यस सर।
डेरिवेटिव और इंटीग्रेशन। ठीक है? अब इस चैप्टर में वी हैड नो क्लू, वी न्यू some aspects of motion like velocity, acceleration, displacement, but we had no idea why the motion happens. In the chapter of laws of motion, we are going to know the why of motion. होता क्यों है? Why it happens? Which was not addressed in this chapter. इसमें नहीं सिखाया था. Okay, so let's come to the Newton's first law of motion. What do you think it is? क्या पढ़ा आपने पढ़ा अभी तक स्कूल में? Every body, anybody or everybody continues in its state of, जो भी करंट उसकी स्टेट है, अगर रेस्ट में है तो रेस्ट पे ही रहना चाहिए।
हाँ, और मोशन में तो
मोशन in a straight line unless compelled by some external force। सबसे इंपॉर्टेंट वर्ड है एक्सटर्नल फोर्स। तो कोई भी बॉडी, मान लीजिए यू लेट्स टेक एन एग्जांपल, ओके, लेट मी गिव एन एग्जांपल। यू आर इन अ बस, दैट्स योर बस। You're sitting on the window. The bus is moving with certain velocity v. Suddenly the driver puts a brake. Brake is what? इट्स एन एक्सटर्नल फोर्स, माने टायर पे फ्रिक्शन आ जाएगा
हाँ
तो बस रुक जाएगी।
ठीक है सर।
तो आपकी जो आपको, इफ यू वर पार्ट ऑफ द बस, व्हाट डिड यू वांट, दैट यू शुड स्टे इन दैट मोशन, बट किसी एक्सटर्नल फोर्स ने बस के मोशन को बदल दिया। सो आपको क्या लगेगा, यू विल गो लाइक दिस, आगे की तरफ,
हाँ
even though the bus is becoming slower by the application of the brake, you will feel a forward movement because you're attached to a system which was in a. So what does it mean? That you want to continue to be in the state of motion. That is why you move forward.
yes sir.
This property of yours, which makes you say that you will continue to be in the same, you want to be in the same state, right? This property is studied in this Newton's law.
ठीक है सर।
So the bus was moving with 20 meter per second. You were also moving with 20 meter per second. An external force stopped the bus and the velocity of the bus finally became 0. You also, when the brake was applied, you went forward because you had a tendency. Otherwise, why would you move forward? आप आगे क्यों जाओगे नहीं तो? Why do you experience that forward movement? Because you want to continue to move with a 20 meter per second. Right? Similarly, if you have a body in rest, okay? So I have to bring it to motion. ठीक है? This is rest. This is motion. Who can change this? Who can change this state?
Friction.
External force.
Friction. yes sir.
कोई बाहरी ताकत, इसको कोई पुश कर दे। अगर आप पुश नहीं
हाँ सर, तो
करोगे,
फिर
it will continue to remain in rest. But if you
Yes, sir.
apply an external force, it changes its state from rest to
yes sir.
motion. तो दो स्टेट्स हैं। अगर एक बॉडी रेस्ट में है तो रेस्ट में ही रहना चाहेगी, और अगर एक बॉडी मोशन में है तो मोशन में ही रहना चाहेगी। लेकिन अगर आप रेस्ट से मोशन में लेके आना चाहते हो, you have to apply an external force. If you want the body to move from motion to rest,
तो इसमें भी एक्सटर्नल फोर्स।
correct. Bus is an example. You were in motion. Suddenly the brake were put. You had a forward jerk because you wanted to continue. It says you continue would like, the body continues in whatever state it is, rest or uniform motion. But ब्रेक लग गई, एक बार झटका लगेगा आपको सिर्फ। उसी तरह से when the bus starts, what happens? Which state are you in when the bus starts? Rest. An external force, which is the engine of the bus, gives the external force. You are sitting on the chair. Which direction will you go now? Will you go forward or backward?
Backward.
Correct. Because you want to stay there, na? You want to maintain your state. Got it?
Got it. True.
Okay. So let me give you some questions on this. Okay. Small quiz. Conceptual quiz. which we can discuss.
Yes.
Okay. Simple exercises basically to right, got it. I'm just sharing it. Got it. थोड़ा सा हल्का सा डिफिकल्ट है, हल्का सा डिफिकल्ट क्वेश्चन है।
ट्राई करते हैं।
हाँ जी,
चल ट्राई करते हैं।
of course. So a situation is there where a person is in the vehicle. Okay, more discussion oriented है, and this person is hit, और ये होता है practical life में. The person is hit by another car from behind.
Okay.
So this person generally, it's a whiplash injury. What happens is this person neck gets broken. He's sitting at rest, and on the chair or front seat or back seat, a speeding vehicle comes in and strikes it. And generally what happens is the neck gets broken. It's a medical term, whiplash.
Yes, sir.
Why do you think this happens? The neck gets broken. He's in rest, right? So his state is rest. A speeding vehicle comes in and gives it a external force. बहुत तेज, छोटी मोटी फोर्स नहीं है ब्रेक की तरह, जैसे कि ब्रेक तो बहुत छोटी फोर्स होती है, सो इतनी हार्मफुल नहीं होती. Understood?
Yes, sir.
But in this case, the force is minor
Force.
type of force.
Okay. तो स्पीडिंग व्हीकल
हाँ,
जब हिट करती है कार को, द पर्सन विल गो फॉरवर्ड, तो प्रेशर पड़ेगा ज्यादा, फोर्स
force,
बढ़,
not pressure.
तो फोर्स बढ़ जाएगी उसकी,
Yeah.
so it can cause the neck injury because them suddenly.
आपकी neck जो है, right, it doesn't touch the seat, है ना?
हाँ.
So if I draw your neck, and this is your back resting on the seat, So the force comes and hits here, right?
Yes, sir.
But this is in rest.
Hmm.
तो ये तो रेस्ट में रहना चाहती है, लेकिन जो बैक है दैट मूव्स फॉरवर्ड. So the
Yes, sir.
neck experiences an unequal force. The force is not coming on the neck, it is coming on your back. तो आपका बैक तो ऐसे मूव करता है बट नेक वहीं रह जाती है.
Hmm.
तो इस जगह पे it breaks
Yeah.
because of the fact that neck wants to stay in rest,
Hmm.
but it is connected to the back.
Yes, sir.
The back is in motion, but the neck is not. तो कनेक्शन है ना आपस में. एक अगर दो चीजें जुड़ी हों आपस में
Hmm.
और एक के ऊपर फोर्स आ जाए, वो तो आगे चलना शुरू हो जाए, ये वाला पोर्शन ना हिले तो क्या होगा? ये
Sir, break.
टूट जाएगा ना. इट विल ब्रेक.
Yes, sir.
इट विल नॉट बी एबल टू हैंडल दिस. ये आगे बढ़ रहा है, ये आगे नहीं बढ़ रहा, जुड़े हुए हैं आपस में, तो टूट जाता है यहाँ से. ब्रेक्स. दिस इंजरी इज कॉल्ड एज अ whiplash injury. Another example of same body, the human body same, but one body is wanting to, the neck wants to be in the state of rest.
Sir. But
Back is hit, the force gets transmitted to the back,
Hmm.
but the force is not getting transmitted here
Okay, sir.
on the neck.
Hmm.
ठीक है.
और सर अगर ये व्हीकल रेस्ट की जगह मोशन में होता तब एक स्पीडिंग व्हीकल ने हिट करा होता.
हाँ, तो भी अगर नेक आपकी अलग है सीट से, हवा में टंगी हुई है, तो अनइक्वल फोर्स तो तब भी हो जाएगी.
Okay.
What you need is unequal force.
Hmm.
Back will still have a force, neck will still not have a force. So again, there is a possibility that your neck may break. But you're a neck, right? You're saying my neck is in motion now because I am part of the car.
Hmm.
Yes, but the force which is coming on you from outside does not create the same force on your neck as it does on your back.
Okay, sir.
जो
जो
आपकी बैक पे फोर्स लगती है आके पीछे, जो धक्का लगता है आपको, वो नेक पे नहीं लगता. नेक इज सेपरेट. आपके पीछे पीठ पे लगेगा वो धक्का, राइट? अगर ऐसे ही कोई आपको पुश कर दे पीछे से बहुत तेज पीठ पे, राइट,
Yes, sir.
बी वेरी केयरफुल. उसकी नेक पे अगर वो फोर्स नहीं लग रही और आपने इतनी तेज इंपैक्ट मारा उसको, तो उसकी नेक टूट सकती है पीछे से धक्का मारने से, बिकॉज नेक वांट्स टू बी इन रेस्ट,
Yes, sir.
whereas the lower body wants to go forward.
Okay, sir.
Got it?
हाँ.
So
sir,
the neck will get broken in the condition of unequal force. An unequal force is a result of the fact that the neck is not facing the force which comes from the impact of the speeding vehicle. The back does.
Yes, sir.
This wants to stay in rest. तो ये तो आगे की तरफ चलना शुरू हो जाता है.
Hmm.
इसको तो धक्का मिल गया, ये रेस्ट पे है.
हाँ.
So the neck is at rest. So there is an unequal force on the rest.
Yes, sir.
Okay, so that is why it breaks. All right. Okay. Okay, when you remove the dust from a carpet, hanging carpet, कई बार carpet को टांग देते हैं तार पे, so wire, and you put a, carpet like this. This is a carpet, and you beat it with a rod, the dust comes out.
Yes, sir.
मिट्टी धूल झाड़ने के लिए ऐसे भी करते हैं कपड़े को, उससे क्या होता है?
तो धूल निकल जाती है।
क्यों क्यों निकलती है? दैट्स अ क्वेश्चन, राइट?
सर
व्हाई इज द क्वेश्चन?
सर अनइक्वल फोर्स की वजह से वापस।
किसके किसके ऊपर?
सर फोर्स विल बी ऑन द कारपेट बट डस्ट रेस्ट करोगी तो वो निकल जाएगी,
हाँ,
क्योंकि कारपेट को हम हिट करेंगे रॉड से तो
तो
कारपेट की
कारपेट तो हिल
जगह।
जाएगा अपनी जगह से,
हाँ।
carpet will go,
यस
but
सर।
the dust particles will remain there itself, so they will fall down.
यस सर।
Similarly, on a tree, जैसे ट्री है, इसकी एक डाल है ये, you have a lot of leaves here. Okay, dry leaves है मान लो. You shake the branch. Why do these fall off? गिर क्यों जाते हैं पत्ते?
तो वापस अनइक्वल फोर्स होता है।
Yeah.
तो ब्रांच को हम हिलाएंगे तो ब्रांच लूपिंग में आ जाएगी, बट लीव्स तब भी रेस्ट पर हैं
हाँ,
तो लीव्स गिर जाएंगे।
तो अनइक्वल फोर्स आ गई, राइट? वन जिसके ऊपर फोर्स लग रही है वो तो मोशन में आ गया, which is the branch, but the leaves want to continue to stay in the state of rest. They will fall off. ठीक है जी? Okay. What else can we think? Okay. So this was this is the concept of all the examples we studied were the examples put under the category of inertia of rest.
Okay.
Okay. Which means in normal English, the tendency to remain in rest and not change to motion. ठीक है? मतलब if somebody says I want to stay in rest, they are telling you they have an inertia of rest. I have inertia of rest, which means I want to stay in rest. Some students have inertia of not doing questions. They don't want to do questions. They have an inertia. That means they want to stay the way they are. The other word for tendency of which is a state of motion or rest, the other is inertia of motion.
Inertia.
Now I want to continue to be in motion. Right? So if you start a car and you move, you feel a backward jerk. But if you are already moving and then you stop, what happens to your upper body?
Forward.
Forward. So it wants to stay in motion. That means it has what is called as a inertia of motion. ठीक है? Okay. All right. What could be another example of inertia of? All right. If you studied projectile motion, so this is your aeroplane. A packet is dropped. You know the packet goes like this because initially the velocity of the packet is same as the velocity of the aeroplane. तो वो जो पैकेट को वेलोसिटी मिलती है, तो पैकेट वाज इनसाइड द प्लेन. Inside the plane, it was in motion.
Yes, sir.
The moment it leaves the plane, it leaves with the velocity of the plane. Right? So it continues with its motion. It demonstrates inertia of motion. It wants to stay in the same state. If you have a parachute going up, with a velocity of 5 meter per second. You drop a box from here. Just leave it with your hand. First, this box will go up with a velocity of 5 meter per second.
Okay.
Because it also has the same, it wants to continue to maintain its inertia of motion.
Okay.
Obviously, it will reach some point and then it will start going down.
इसका
हाईएस्ट पॉइंट तक जाएगा, वहां पे फाइनल वेलोसिटी 0 हो जाएगी. राइट. सो न्यूटन का जो पहला लॉ, इट ओनली डील्स विद द टेंडेंसी. हाउ डू ऑब्जेक्ट्स बिहेव in the absence of external force? Objects can either have an inertia of motion or inertia of rest. In order to change the inertia, which is a state, a sophisticated word for state of rest, state of motion, you need an external force. नहीं तो आप बदल नहीं सकते किसी भी चीज का. External. Correct?
Yes, sir.
All right. So this was the first idea he gave. Inertia means basically you want to continue to be the same. You don't want any change.
Okay, sir.
Huh? That is what it indicates.
Okay, sir.
तो आपको पहला क्वेश्चन है, when sitting in the bus, the brakes are applied.
Yes, sir.
The bus was in motion. Should the people in the bus move forward, backward, or remain intact? क्या होगा?
So forward.
Yeah, because people will continue to be in their, would like to be in the state of motion, right? Or they are in motion because of inertia in motion.
Yes,
So
sir.
they want to move forward only. Okay. So Newton का जो law है, first law, if you notice, right? It also deals with the state of rest
Yes, sir.
and state of motion. Okay. Now there is something called as inertia of direction.
Direction. Okay.
Again, wanting to be in the same direction. Will not change the direction unless an external force is given to it.
Yes, sir.
ठीक है? Let's say if you have a situation where you have a cheetah, okay, and it is trying to catch maybe a deer. Okay, have you seen that when the chase happens, the deer goes like this, zigzag?
Yes, sir.
Why? Because cheetah when the cheetah is following them, cheetah develops an inertia of direction. It wants to continue in the same direction. To change the direction to follow the deer continuously is very difficult for it, and The deer is aware of this. That if cheetah starts running with 75 miles per hour in a particular direction to chase me, it will catch me.
Yes,
Finally,
sir.
it will catch me because it can run faster than me.
Yes, sir.
But cheetah knows if I change the direction suddenly to this direction, for cheetah to change the direction is very difficult because cheetah has a whatever direction I have, I am happy to have.
Inertia of direction.
Correct.
Yes, sir.
Right?
Yeah.
All right.
But cheetah तो indirectly change तो करता होगा. Like
करता है बट उसका बहुत उसमें टाइम वेस्ट हो जाता है और बहुत ज्यादा उसको एफर्ट लगता है तो थक जाता है वो. It's very tiring to continuously you run straight one day. Try and run very straight. And then run zigzag. If you run zigzag, you will lose more calorie.
yes, sir.
Because you have to halt na and change. Halt and again accelerate. आपको एक जगह पे आके पॉइंट पे रुक के मुड़ना पड़ता है ना थोड़ा सा.
Yes, sir.
Which is very difficult.
The slows it down.
टाइम वेस्ट हो गया ना आपका रिएक्शन में. To react to the cheetah is very difficult.
Yes, sir.
Clear है ये?
हाँ sir.
Okay. Okay. So let's do one thing. Let's have a glass, okay? And glass के ऊपर we put a paper and then we put a coin on it. And then suddenly we pull the paper from the
Glass.
below the coin. What happens?
The coin falls in the
Where?
glass. In the glass.
Why? You have to explain your observation. Why does it happen? You have understood the situation. This is your class. You keep a piece of paper on it. Right?
Yes, sir.
And now you keep a coin. My question to you is, if I suddenly pull this, why does the coin go down? Suddenly. That means no time is available. It happens too fast.
Because sir, coin is at rest.
Correct. Inertia of
Rest.
rest. Correct. So it goes down.
Yes, sir.
All right. It does. Agreed.
So, but sometimes it comes with the paper.
That means the inertia was not sufficient. So inertia की quantity भी important है. Right? That means inertia का सिर्फ inertia होना काफी नहीं है, उसका quantity होना भी काफी है.
ठीक है सर.
भारी कॉइन नहीं इतनी आसानी से जाएगा, हल्का फुल्का कॉइन हिल जाएगा. Okay? So which brings to the idea of mass.
Yes, sir.
Mass is a measure of inertia. Kilograms.
Grams, kilograms.
The more is your mass,
the more is the mass.
so if you have a mass which is 5 kgs versus a mass which is 10 kgs,
Yes,
the
sir.
mass of 5 kg will show less inertia of rest, less inertia of motion, and less inertia of direction. And the inertia which will be exhibited by 10 kg will be double.
Yes, sir.
Double the inertia of rest, double the inertia of motion, and double the inertia of direction.
Yes, sir.
So mass and inertia sometimes are used interchangeably, but the correct definition is what measures inertia. It Mass is a measure of inertia. If you have a situation like this, where there is a bus and on top of the bus you have a lot of luggage. Okay? The bus is moving. Suddenly the bus puts a brake.
Yes, sir.
In which direction will the luggage go? Forward or backward? Slide. बांध के रखा है लेकिन थोड़ा बहुत स्लाइडिंग अलाउड है.
Forward.
Forward. Inertia of motion. Okay?
But what if the luggage falls?
Was
What if the luggage falls?
fall.
Hmm.
हाँ, can. अगर बिल्कुल बांध के नहीं रखा, it may slide and it may fall in front. जो होता भी है. Can.
Okay, sir.
Okay. All right. Let's say in a uniform circular motion. Okay, so here is your uniform circular motion. The body always has a velocity which is tangential to the circle. At any point, it is direction of the velocity is this. If you consider this point, it is like this. Now, this is a string. This is a stone. If the string breaks away, if the string breaks at any instant, for example, the string breaks here at the top point. In the normal circumstances, the stone will keep on moving in a circle connected to the string. But if you cut the string, then what happens to the stone? The stone will go in the direction of the velocity. Inertia of direction. It will want to continue, but you're not allowing it because you have a string.
Yes, sir.
The string has a tension, and the tension provides it a centripetal force to keep it intact in the circle. जैसे ही ये इधर जाने की कोशिश करता है, सेंट्रिपिटल फोर्स कहती है भैया तो इधर आ जा, तो ये गोल गोल ही घूमता रहता है फिर ये.
Yes,
So
sir.
centripetal force keeps on changing its direction of velocity, but the force is always directed towards the center. ये string है, but the velocity here is this. अगर यहाँ string कट गया, ये stone it will go straight.
Yes, sir.
Inertia of direction. Clear?
Yes, sir.
All right. So much for Newton's first law. Pretty straightforward.
Yes, sir.
Okay. Let's go to the Newton's second law, which is where a lot of calculation is there. Most of the questions are based on Newton's second law. Newton's second law of motion. We have already introduced the concept of something called as an external force in the Newton's first law. It has already been introduced.
Yes, sir.
But what is an external force? We have not defined it, right? What is it? How do you calculate it? This law will tell you how to measure that external force. And how does that external force act on the bodies and what does it do to the bodies? What is the external force? How to measure it? How does it impact other bodies? Okay. Let's say you have a body which is of mass m moving with a velocity v1, and now it is applied by a force, external force F, and that force changes its velocity. ठीक है? External.
Okay, sir.
Before you learn Newton's second law, you should know what is the concept of momentum. What is momentum? The momentum is amount of motion contained in a body. Of mass m and velocity v. How do we measure it? By the product of, it's a vector. The quanta of motion inside you tells me how much momentum you have. For example, if I know your mass is 60 kgs and you're running with a velocity of 5 meter per second, somebody says, how much motion do you contain? I will tell him you are asking me momentum.
16 to 5. 300 kgs. Okay.
There is another body, but the velocity of that body is half meter per second. Momentum of this body, how much motion is contained by this body? Same.
Yes, sir.
There's another body,
Mhm.
50 kgs, but the velocity is
6 meters.
momentum is equal to
6. 300. 300.
do you see that the quantity of motion a body contains is dependent on the mass and velocity product?
Yes, sir. Mass. Yes, sir.
Two things it depends on.
Mass and velocity.
Yes. Now my question to you is, compare the momentum of two bodies. One body, the mass is 6,000 kilogram, like an elephant. The velocity of this body is, and there's another body which is only 6 kgs, very small, but the velocity is,
200.
which one of these two, if it collides with you, will give you more impact when it collides with you? आपको झटका किससे लगेगा अगर ये आपसे टकरा गए? If they collide with you, just whom will you feel has more motion when they strike you?
So,
So we will calculate momentum first. Quantity of motion पता लगाना है ना पहले तो.
600. 60. So,
This has more motion.
yes, sir.
Imagine a 6-gram bullet, 6-gram bullet moving with a velocity of
500.
30 kilogram. तो मास होना काफी नहीं है. You need both. ये समझ में आ रहा है? The quantity is not being decided by only mass. Lot of people think जो बड़ा है या ज्यादा तेज चल रहा है उसी का मोमेंटम ज्यादा होगा. ऐसा नहीं है. If I make this velocity, अगर मैं 60 ग्राम कर दूं ये,
हाँ,
तो 300 तक आ जाएगा ये.
yes, sir.
और 6000 किलोग्राम के पास इतना मोशन है, उससे 5 टाइम्स हो गया बुलेट का.
Yes, sir.
This is a 6000 kilogram body, but look at the speed, nothing.
Nothing.
This is a bullet. It's moving at such a fantastic speed. So much momentum. So momentum is measure of what?
It's the product of velocity and mass.
ध्यान से पढ़ लो. How to calculate momentum समझ में आ गया आपका आंसर.
हाँ,
But what does it measure?
the amount of motion in a body.
How do you calculate it?
Mass into velocity.
सही है.
Yes, sir.
The idea we will finally reach is Newton's second law. But before that, we have to learn what is momentum. Got it? All right. Now, momentum is a vector, remember. It has a direction. So a body which is moving in x-axis of 5 kgs and velocity is equal to 2 meter per second in I direction, the momentum is how much? I का मतलब है x-axis. This is a unit vector. पता है इसके बारे में I?
सब पता है सर.
Okay. And similarly, if there is a body which is moving in y-axis,
J.
J. So 5 kilogram, but the velocity is 2 meter per second, J.
तो हम तो 10 मीटर per second J.
Sorry, यहाँ पे भी किलोग्राम लिखना चाहिए था, right? Got it? So direction is also associated with the concept of momentum. So you can't say these two bodies have same momentum, because one body is in I, the other is in J. So we can't say, but magnitude wise they are same, value same. We can say this is allowed.
Okay, sir.
Got it? Now, but हम तो पढ़ रहे थे न्यूटन सेकेंड लॉ, और अभी मोमेंटम हमें पहले समझना पड़ता है बिफोर वी स्टार्ट स्टडिंग व्हाट इज न्यूटन सेकेंड लॉ, करता क्या है वो, पहले मोमेंटम का आइडिया डेवलप करना जरूरी होता है.
Okay, sir.
ऑलराइट, now let me tell you, there is a situation, and now we are moving towards Newton's second law, where the momentum of a body, which is the amount of motion it contains,
Oh, sir. Okay, sir.
something happens. This is initial. Something happens and its momentum becomes so this was the amount of motion contained earlier, and then something happens, the amount of motion becomes this much. What has happened? Can we say that there is a change in momentum?
Yes, sir.
Let's calculate.
Okay.
So momentum is changed by a certain amount, right?
Yes, sir.
Now let me tell you, this momentum change happened in a certain time. एकदम नहीं हुआ change. It took some time to change it, right? So let's say the time taken to change the momentum
Yes, sir.
is delta t. Time लग गया बदलने में. It took you 2 seconds.
Okay. So time, delta T.
हाँ, to change it. Effort लगा motion बदलने में उसका. It had a quantity of motion. It had a new quantity of motion, but it took you some time to change it.
Yes, sir.
Somebody said, in 2 seconds, you have changed the momentum to this extent.
C plus. Thank you, sir. Okay.
In 1 second, how much change will you bring?
So divide कर देंगे.
Correct? Unitary method.
Yes, sir.
Look at this, what I'm doing. Kilogram meter per second लिख रहा था पहले मैं. अब divided by time भी करा है.
Yes, sir.
Right? तो मैंने क्या निकाला है finally? I found out
So
ये निकाल लिया मैंने.
second. Yes, sir.
Got it? और इसके यूनिट्स बड़े इंटरेस्टिंग हैं.
हाँ.
Now let me tell you what is Newton. यहाँ तक any doubts in your mind that come? We
No, sir.
did something, that something is not known to you, but we did something and the momentum changed in 2 seconds.
Yes, sir.
Okay, let's move forward on this. Now let me state the Newton's second law of motion, and we will relate to what we have understood from the above discussion, right? So Newton's second law states, okay, this is just a statement, the rate of change of the rate of change of momentum of a body, मतलब ये the rate of change of momentum body is proportional to the, अब देखना बड़ा इंपॉर्टेंट वर्ड आने वाला है, एंड ध्यान से पढ़ो, दो बातें नोट करनी है। जो मैंने बोला था कि समथिंग हैपेंड and there was a change of momentum, then I divided it by time, then I said, so that means that momentum got changed at some rate which is this, 1 second में कितना चेंज हुआ, यही बोला था मैंने। Look at the sentence. Your volume is very low.
Hello?
Bit better.
The rate of change of momentum of a body is directly proportional to the external force applied on the
Yes,
body.
correct. Which means जो कुछ करा था ना हमने मोमेंटम बदलने के लिए,
हम्म,
वो जो है, जो मोमेंटम, उससे मोमेंटम चेंज हुआ और हमने रेट निकाल लिया, किस किस रेट से वो बदल रहा है, एक से हर सेकंड में। एवरी सेकंड मोमेंटम इज अंडरगोइंग अ चेंज। दिस स्टेटमेंट इज रिटन लाइक दिस, दैट द एक्सटर्नल फोर्स विच यू अप्लाई ऑन द बॉडी, बॉडी के पास मोमेंटम पहले ये था, ये किसी बॉडी का ही मोमेंटम है, फिर ये फाइनल मोमेंटम ऑफ द बॉडी है। अब जो एक्सटर्नल फोर्स लग रही है, हम बोल रहे हैं इज प्रोपोर्शनल टू, ठीक है, सो एफ एक्सटर्नल बिकम्स इक्वल टू, और ध्यान से देखो अगर आप, तो डेल्टा पी इज m final velocity minus initial velocity, new amount of motion minus the previous amount of motion। यहां पे भी हमने यही करा था, सब्ट्रैक्शन, p final minus p initial, वहां पे भी यही करा था, p minus, तो अगर मैं इसमें से m कॉमन ले लूं, मास तो नहीं बदलेगा बॉडी का ड्यूरिंग द मोशन, इट रिमेन्स सेम. So my delta p is this. ठीक है. This quantity Vf minus Vi upon delta t, if you remember equation of motion, the change in velocity divided by the time. So F external came out to be proportional to m into delta V by delta t, and this is called as acceleration. So who brought this change in momentum? This is that agent which has the power to bring change in momentum of a body. This is the force or the agent that can also change the inertia of a body, inertia, the state. If you are at rest, it can bring you to motion. If you are in motion, it can bring you to rest. Also, and therefore it also has the power to change your momentum. If you are in rest, let me say, so here is a body which is at rest. And this now body is moving with a velocity of, in a time of, so in 0.01 second, its inertia has got changed. It was at rest, now it is in motion, which is possible through what? कौन कर सकता है ये?
External.
Correct. So your first answer is correct. Good answer. So you recognize external force has some powers. Now my question is, I want to measure how much is this force. ये फोर्स है कितनी, उसका मेजरमेंट का मेथड देखो ऊपर क्या है. मास निकाल लो दिया हुआ बॉडी का, और चेंज इन वेलोसिटी निकाल लो और टाइम से डिवाइड कर दो. मने बेसिकली आप ये कर लो, फाइंड dp बाय dt. मने फाइंड, अगर आपने ये निकाल लिया तो आपने क्या निकाल ली? क्योंकि एक्सटर्नल फोर्स किसी का मोमेंटम बदल सकती है, तो हम उस बॉडी का मोमेंटम में चेंज निकाल लेते हैं और उसको डिवाइडेड बाय द टाइम कर देते हैं, तो हमें रेट ऑफ चेंज ऑफ मोमेंटम, द रेट ऑफ चेंज ऑफ मोमेंटम, इतना लंबा बोलने की जरूरत नहीं है. हम बोल सकते हैं कि द एक्सटर्नल फोर्स अप्लाइड इज इक्वल टू द रेट ऑफ चेंज ऑफ मोमेंटम ऑफ दैट बॉडी. जिस बॉडी के ऊपर आपने फोर्स लगाई थी, इट विल अंडरगो अ रेट ऑफ चेंज ऑफ मोमेंटम. अपने आप नहीं हो जाएगा किसी का रेट ऑफ चेंज ऑफ मोमेंटम. यू कैनॉट चेंज एनीवन्स मोमेंटम without application of force. You cannot. It is not possible. There is only one way you can change the momentum of a body, which is by application of external force. And if you find the rate also, then you can find कि उसके ऊपर फोर्स कितनी लगी थी. स्टडी बॉडी को कर रहे हो और बॉडी की मोमेंटम चेंज से एक्सटर्नल फोर्स की जानकारी प्राप्त कर रहे हो. You're studying the change in momentum of the body. In this case, how much is the final momentum?
divided by 0.01.
What is the initial momentum? What is the change in momentum? How much time it has taken?
0.01.
इसी को बोलते हैं इस बॉडी का मोमेंटम चेंज इसलिए हुआ था क्योंकि वो 500 न्यूटन फोर्स उसके ऊपर लगाई गई थी. तो बॉडी का मोमेंटम चेंज निकालने से हमें मालूम चल गया कि ये कितनी फोर्स थी, वो ढूंढ ली हमने. सो इफ यू डोंट नो द फोर्स ऑन द बॉडी but you know the rate of change of momentum which is brought on by the force, you can find the value of the force. So force is nothing. If you have to find force magnitude, see what it does to the bodies. It does this to the body. What is it doing? It is bringing in a rate of change of momentum. If you calculate this thing about a body, which is the rate of change of momentum of the body, if you calculate this, you will be able to find how much force acted on it to bring this change. बॉडी की जो फिजिकल क्वांटिटी है वो कौन सी बदल रही है? बॉडी का क्या बदल रहा है?
Momentum.
करेक्ट. एजेंट कौन है जो बदल रहा है?
External force.
करेक्ट.
अच्छा.
इन दोनों का आपस में रिलेशनशिप क्या है? रेट ऑफ चेंज ऑफ मोमेंटम अगर निकाल लें, ये डेल्टा है ना, चेंज.
अच्छा.
Body undergoes a change in momentum in time delta t. I am only looking at the body. I have no clue how much force you applied on the body. And now I ask you, I won't let you see how much is the force just by using change in momentum and the time it took you to change the momentum. Please tell me how much force was there. You say, no problem. I am studying the body. I found out the change in momentum of the body. I am going to divide it by the time it took you. And I will indirectly tell you the external force which was involved in change of momentum. So if you know a body is undergoing a rate of change of momentum, can you say you also indirectly know the force being applied on the body?
Yes, sir.
कह सकते हैं ना?
हाँ.
This is what Newton's second law is all about.
Okay.
And obviously, if delta P is the change in momentum of a body, for example, the overall momentum change a body shows is 2 kilogram meter per second in the direction of I. And the time it takes to change this momentum is 0.1 second. If I calculate the force indirectly through the measurement of, then I will get an answer of, and this thing, whole thing is known as 1 kilogram meter per second square, is also written shortly as do you see that I'm also going to write I here because the momentum change is in I direction, and therefore force is also in the, if you go back to the rule, so I'm going to complete this and say, look at the rule now. Read this.
The change takes place in the direction of the applied force.
Absolutely.
Okay.
Whatever is the direction of change of momentum is the direction of the force also. You cannot say that momentum has changed in Y, but the force is coming in X. Not allowed. Questions?
No, sir.
Okay. Let's do one thing. Let's take a 5-minute breather break. हाँ जी, I'm back. Are you back?
Yes, sir.
Interesting?
Yes, sir. It's interesting.
All right. Let's do some practice by way of questions now. Okay. Simple questions, very basic questions. Nothing complicated. Very concept oriented question, okay? I'm just copying them. We won't do numericals right now. Bit too early. Let us see first only the concept part of it.
Okay.
Just give me 1 second now. Let's undergo these and see what. देख रहे हैं क्वेश्चन देख रहे हैं? Let me do one thing. Let me copy this to page number 2. आप भी पेज नंबर 2 पे आ जाओ. आई एम एडिंग अ पेज. दिख गया? राइट साइड पे नीचे. So I've just copied these questions. Hope they're visible to you now. Let's go through them. All right, start.
Force causes change in motion.
हाँ जी.
The net force causes change in motion.
Okay. Example.
Like car or example we take.
Okay. Which means it was at rest and
Car
you.
came
ठीक है.
from
Okay.
such as to move altogether. Second half.
Okay. Second, sixth we have not done. Sixth अभी रुक जाओ. Seventh भी रुक जाओ.
Okay.
Okay. Eighth. This is an example of circular motion in which the body is in circular motion. The speed of the body throughout the circle remains constant. यूनिफॉर्म सर्कुलर मोशन में जब भी बॉडी होती है, although the I told you right, the इधर भी वेलोसिटी 5 मीटर पर सेकेंड है, इधर भी 5 है, इधर भी, हर जगह पे 5 ही है. ये लीनियर मोशन है ही नहीं. So there is a net force which is directed towards the center, called the centripetal force. But the velocity does not change. So therefore, so the answer, a situation is uniform circular motion. Ninth.
Despite such situation. So ये भी circular momentum वाला question.
हाँ जी.
So ये circular momentum वाला question.
Come again.
So question number 9.
Hmm.
So similar question to circular momentum.
Your voice is breaking a lot. रुको. फड़फड़ हो रही है बहुत, पता नहीं. Let me just check my speed. Let me do a speed test on my internet. Because your voice is breaking for some reason, I don't know. मेरा इंटरनेट का स्पीड बहुत स्लो हो गया. Yeah, my speed is very low. Let me just switch off my camera. See if it is better. अब बोलो.
So I'm saying कि question 9 be similar है circular momentum because
No. Hold on. So see, in a motion like this, the body is having 5 Newton here and a 5 Newton here. So net external force is 0.
yes sir.
लेकिन बॉडी 5 मीटर पर सेकेंड के वेलोसिटी से चलती जा रही है. वेलोसिटी बदलने के लिए तो वी नीड एक्सटर्नल फोर्स ना. सो लुक एट दिस. इट हैज अ नॉन जीरो वेलोसिटी and there is no external force because it is getting balanced. लेकिन फिर भी वेलोसिटी है. तो ऐसा भी होता है कि बॉडी चल रही है और नेट एक्सटर्नल फोर्स 0 है, क्योंकि फोर्स डज नॉट कॉज मोशन, फोर्स कॉजेस चेंज इन मोशन. ये पढ़ा था ना हमने. नेक्स्ट.
Projection. This means straight upward external force acting on the top. Okay.
So the body goes up.
Exertion due to gravity.
What is the net external force? mg. ग्रेविटी तो हमेशा लगती रहेगी ना. At the highest point you will have g. Throughout the motion g रहेगी ना, downward. Got it? So even if it stops, so what?
The highest point to stop.
है ना. Highest point पर रुक जाएगी, but the force will still act on it. Earth will still pull it down. Okay.
Give an example of different external forces. Acting on the same system of product, this will produce different acceleration.
ठीक है, you can show different values of force. ठीक है, don't do, रुक जाओ. Let's do this.
The signal from the system is zero. No internal forces acting on it. What about the internal force? Explain me
Yes,
about
there are no external forces.
it. So,
We have not studied internal forces, so leave it. The 13th.
constant non-zero force is applied on an object. What can you say about the velocity and acceleration of the object?
So it's a non-zero force.
तो तो चेंज नहीं होगा ना सेम रहेगा
क्यों? Velocity will change because of the force. Force can change the velocity, right? Force can change the amount of motion.
Yes, sir.
If you have a body, it was moving with a velocity of 5 meter per second, and you apply a force of 5 newtons on it, external force, मान लो ये 1 kg है. This is an external force. The initial momentum is how much?
Okay.
Right?
Yes, sir.
मोमेंटम बदलेगा ना
बदलेगा है इसका
अगर एक्सटर्नल फोर्स. तो ध्यान से पढ़ो क्वेश्चन को.
the constant non-zero force is applied to an object. What can you say the velocity and acceleration of the object?
Velocity will change,
Yes, sir.
and we know force is given by delta p by delta t, which is written as m into delta v by delta t. मास तो बदलता नहीं है मोमेंटम में,
हाँ
वेलोसिटी बदलती है. और इसको क्या बोलते हैं क्वांटिटी को?
acceleration.
So body will accelerate
Yes, sir.
and the velocity will also change.
Yes, sir.
That means the amount of motion has changed, and there is a rate of change of motion also.
Yes, sir. Okay.
Simple questions again, not very difficult ones. ठीक है, बहुत simple, which can be done in one sentence, so that you get comfortable with this terminology and also with the formulas. All right. So here is a situation. You have a vehicle moving with a velocity of 20 meter per second. You see a boy in front of you. Okay, and you apply a brake. You apply the brake and stop the body in 5 seconds. Vehicle. The mass of the vehicle is 100 kilograms. And in 5 seconds, the vehicle comes to rest. Right? Question is, how much और एक्सटर्नल फोर्सेस केस में उसका नाम क्या होगा? अलग अलग टाइप की एक्सटर्नल फोर्स होती हैं. एक फ्रिक्शन भी हो सकती है. ठीक है ना? So let us see. comes to rest.
So, the time 5 seconds.
एक वर्ड दे रखा है इन्होंने,
Okay.
यूनिफॉर्म डेसेलरेशन है.
Five. Four.
This is the deceleration. Who is experiencing the deceleration?
The car.
थ्री 300 kgs की थी, 100.
And 400.
Got it? Or you can write it as
Okay.
ठीक है. Let's do another one. Any doubts in your mind कि समझ नहीं आया कुछ? Anything that you want to say? कुछ पल्ले नहीं पड़ रहा या fairly straightforward है. अगर कोई ध्यान से इसे कर लेगा तो मतलब it's not that hard. It is, you should know who's changing the amount of motion in a body. That's all. All right. Slightly vector-driven question. So there is a force being applied on the body at an angle of 30 degree, and the mass of the body is 2 kgs. So 20 kgs. And the force is, let's say it is 10 newtons. Okay, but it is being applied at an angle. ठीक है? हाँ. Question is, what is the acceleration produced on the body by this force? X-axis में, not Y. जनरली तो आप फोर्स लगाते ऐसे लगा देते हो ना. अगर 10 न्यूटन ऐसे लगा दोगे तो आप लिखोगे फोर्स इज इक्वल टू m इंटू ए. 10 इज इक्वल टू 20 इंटू ए. सो a इज इक्वल टू, लेकिन मैंने ऐसे तो लगाई नहीं ना, हॉरिजॉन्टली नहीं लगाई मैंने. आई हैव इंट्रोड्यूस्ड अ थीटा. ट्राई दिस. Question is, we have to focus on the x-axis, and we know कि change in momentum उसी direction में होता है जहां पे change in force, sorry, force, external force उसी direction में होती है जहां पे जो direction होती है change of momentum की. तो हमें तो इधर x-axis का ही ख्याल रखना है सिर्फ. तो पूरी 10 न्यूटन जो आप दे रहे हो, अगर ऐसे देते तो बहुत अच्छा होता, इजी हो जाता बड़ा. स्ट्रेट अवे ये लगा लो तो एक्स एक्सिस में एक्सेलरेशन आ जाती. लेकिन अब मैंने थोड़े एंगल पे लगा दी. व्हाट चेंज विल यू मेक? What you will do is you will say the force can be divided into two parts. This is 10. This is 30. What is a horizontal component? What is a component opposite to the angle?
So science. Yes, sir. So you can define it.
And we are worried only about
Okay.
horizontal. So what is my horizontal force available to me?
So then cos is 5.
What is the Newton's second law state? Sorry, 5 root 3 is the force. The mass was how much?
Mass is 22.
Mass is 20, right?
So
आगे acceleration. Okay. Now you have a bullet. Okay, so you're
bullet.
firing a bullet. Okay, you fire a bullet. It enters a wall. You fire the bullet with a velocity of 100 meter per second. It enters with a velocity of 100 meter per second. Then it starts entering the wall and it stops after say 20 centimeter. Right? इसका मतलब है जो वॉल है उसने इसको रेजिस्टेंस ऑफर करा है, एक्सटर्नल फोर्स ऑफर करी है, और इसको कहां पे रोक दिया है?
Centimeter.
अंदर 20 सेंटीमीटर में. राइट? तो इसका मतलब एक्सटर्नल फोर्स थी तभी तो इसका अमाउंट ऑफ मोशन बदल गया. अमाउंट ऑफ मोशन 0 हो गया इसका.
So it
एंड
will
मास ऑफ द बुलेट इज 60 grams.
okay.
ठीक है? Mass of the bullet. Now, how much moment? What is the initial momentum of the bullet?
So
सही है?
so
What is the final momentum?
0. So this
मोशन ही नहीं, खत्म ही हो गया. लॉस ऑफ मोमेंटम कितना हो गया? लॉस ही हुआ है.
so loss is 6.
अच्छा, हमें तो फोर्स निकालनी है ना, तो हमें फोर्स का फॉर्मूला पता है एक्चुअली. So we know that force actually, or this can also be written as डेल्टा पी. तो निकाल लिया हमने, डेल्टा टी नहीं पता ना हमें. तो हमें पता लगाना है कितनी देर में ये चेंज हुआ, ये फोर्स कितनी देर तक लगती रही इसकी वेलोसिटी को 0 के लिए. ठीक है? वैसे तो इससे ए भी आ जाता मेरा, मैं सीधा इधर ही डाल देता ना मास के साथ.
हाँ
तो वो इससे ए डायरेक्ट आ जाएगा मेरा।
ए
ये वाला मेथड भी कर रहा हूँ। तो ऐसे भी निकाल सकता हूं मैं, लेकिन अगर आपको dt निकालना है तो बेसिकली आप बोलोगे कि इनिशियल वेलोसिटी थी 100 मीटर पर सेकेंड, फाइनल वेलोसिटी 0 है, डिस्टेंस है 0.2, तो s इज इक्वल टू ut प्लस हाफ ए टी स्क्वायर। ए तो निकालना ही पड़ेगा फिर भी, और टी निकालना पड़ेगा। ए तो निकाल लिया ना मैंने, ए। अगर कोई बोलता है कितनी, ये कितना डिस्टेंस ट्रेवल कर रहा है इसने अंदर, सॉरी कितने टाइम में रुकी, तो वी कैन यूज दिस, v इज इक्वल टू u प्लस ए टी माइनस 25,000 है ना एक्सेलरेशन। सेकेंड इक्वेशन से निकाली थी ना, अभी थर्ड इक्वेशन से, सॉरी, इसमें डाल दिया फर्स्ट में।
हाँ
गॉट इट? डायरेक्ट भी आ जाता, मतलब पिछले चैप्टर से अगर हमें ये पता था, ये पिछले चैप्टर में था ना काइनेमेटिक्स में, इससे मैंने चुपचाप एक्सेलरेशन निकाल ली, फोर्स के फॉर्मूले में डाल दिया, और मुझे मालूम चल गया हाउ मच फोर्स हैज कम, ये डेल्टा m इंटू ए, एम कितना हो गया मेरा, m वॉज ओनली 60 ग्राम्स, और मेरी एक्सेलरेशन है -25 इंटू 10⁻³ ये कट गया 1000 5 6 30। सो द वॉल, जो सीमेंट की वॉल है, उसने ये इसको रेजिस्टेंस ऑफर करा है। फोर्स ही हो गई ना एक तरह से रेजिस्टेंस। एनी डाउट्स? ये वॉइस इज ब्रेकिंग। अभी ठीक है ये आवाज, लाउडर। ठीक है, वी विल मीट अगेन टुडे फॉर अ शॉर्टर ड्यूरेशन ऑफ टाइम एंड कंटिन्यू डिस्कसिंग दिस। ठीक है, I will send you the link and I will just ping you the time then. Shorter class, not long, just to discuss some more numericals on this topic. ठीक है, see you then, bye.